So welcome to GED in Review. My name is Brian Thomas, and I'm going to do a review on the algebra reasoning and the geometry part of the GED. On the algebra part, there's about 55% of it that's algebraic reasoning. So this is the bulk of the test as well. So you'll see a lot of this type of math on there. Remember, you don't have to get it all right, you just got to get some of it right. So let's look at this first problem here. So let's see what we have. Evaluate the expression 2x minus the quantity 4y minus 3 plus 5xc when x equals -3, y equals 2, and z equals -1. So again, we start to see these letters appear. The letter, usually we use the word variable for that. So we have these variables, x, y, and z, and they're usually referred to as unknowns, but since we said x equals -3, y equals 2, and z equals -1, they're now defined, so they're actually known. Now what I got to do is figure out how they fit into this expression. So the relationships, what we got to figure out now is, what does all this mean here? So 2x means 2 times x. And so to represent multiplication, I use parentheses, and I'm replacing x with a -3. So if negative numbers are involved, a lot of times I'll use parentheses for multiplication. Minus then we have this 4 times 2, y is 2, and then minus 3. And then we have plus then 5xz, so that means 5 times x times z. So I'm going to again use parentheses for multiplication. So 5 times x is a -3 and times z, which is a -1. So now that I got this expression laid out, we're now supposed to know what we call the order of operations. And sometimes it's referred to as please, excuse, my dear, and Sally. So again, the P stands for parentheses, and we're supposed to do what's inside the parentheses first. Well, the only thing that really requires doing something inside is this set of parentheses. There's multiplication and subtraction. Here, all there is a -3, and over here inside these parentheses is a -3 and a -1. So those are already simplified, nothing to do. But this here, we got to do that multiplication and subtraction. And based on the order of operations, we got to multiply and then come back and do subtraction. So 4 times 2 would be then this 8. So I'm going to go ahead and bring the rest of the problem down. So I have 8 minus 3. And then I'm going to go ahead and bring the rest of the problem down next to it. Let's see here. Make sure we get this all down correctly. And since I still got subtraction to do, I have to do 8 minus 3, which turns into a 5. And those parentheses are no longer necessary, so I can drop them. So I have 2 times then a -3 minus then this 5 plus then this part over here, 5 times -3 times -1. So I did my parentheses. There's not any exponents. The next thing I look at is multiplying and dividing. Well, there is multiplication to be done, so I'm going to take care of my multiplication. So when I multiply 2 times -3, the way I do it is just multiply 2 times 3, which is 6. And since there's only one negative involved, that makes it negative. And over here, I have 5 times -3 times -1. The easiest way to do it is just go 5 times 3 is 15. 15 times 1 is 15. And since there's two negatives, that makes it turn into a positive. So that's been multiplied. So my multiplication has been done. So now I just bring down my subtraction and my addition. So the last thing I have to do is adding and subtracting. Since there's adding and subtracting, what I like to do in algebra, though, is see it as terms. So the first term is you just circle the first number. The second term, you circle the subtraction sign with it. And the third term, you circle the number and you include the addition symbol with it. So what's in those 3 circles are what you actually add together. So this problem really is the same thing as -6 plus -5 plus 15. Addition order does not matter. So I'm going to just add -6 plus -5. That's going to be a -11. And then you're going to have a -11 plus this 15. I'm kind of running out of room. So -11 plus 15 is going to end up being then 4. So that's how you would do that without a calculator. Now, the GED test, if you do have this nice little GED calculator, it can do this math. I just don't have one on here. So look me up sometime and we could kind of talk about the GED calculator if you want. But you have to have one. So let's move on to the next question. So on March 6th in Northton, the high temperature was 46 degrees Fahrenheit. A strong winter storm hit the town and the temperature dropped sharply to a low of -8 degrees Fahrenheit. What was the magnitude of the change in the temperature that day? So again, the key is that last sentence. What is the magnitude of the change in temperature? So again, that word magnitude kind of represents distance. Or also we see this word change, and change implies a subtraction concept. Remember, if I have two numbers, I want to find their change, how much they change by, that's actually a subtraction concept. So if I want to find the magnitude, that means distance. But the magnitude I want to find is the change in the temperatures, or in other words, the difference in the temperatures. So this actually is a subtraction problem. So 46 take away a -8. So again, in subtraction, we can also see this as a 46. And if you circle the subtraction sign with it, we kind of see that this is really the same thing as 46 plus 8. 46 plus 8 would be then 54. So that would give us then this answer here. Okay. I don't think I even went back and chose 4 on that other one, did I? But yeah, 4 was our answer on this problem over here on this page. So I did all the work and forgot to mark it. All right, so that one would be 54. So again, magnitude really is another word for distance. And the word change actually implies subtraction. And then if you have a calculator, you can just subtract it on a calculator, or you can use the circle method and change this into an addition problem. And remember, in algebra, 2 negatives turns into a positive, because what this really means is the opposite of a negative, and the opposite of a negative is actually a positive 8. So those are equivalent. So on this one here, this drawing is not real clear. So we're going to try to use this following drawing. A lighthouse casts a shadow of 11 feet long. The distance from the top of the tower to the end of the shadow is 61 feet. How many feet tall is the lighthouse? So what we have is this image of a lighthouse, and what we don't know is how tall it is. So this letter H represents its height. What we do know is this across the ground is the shadow is 11 feet, and the distance from the top of the lighthouse to where the end of the shadow is 61 feet. So luckily they gave us a little bit of a drawing to solve this problem. What this kind of looks like is a triangle. So if you kind of bring down a line down through here, you can kind of see that this actually represents a triangle. And this is a special triangle. This is actually what's called a right triangle. In a right triangle, the slanted side is always the longest side. So 61 is actually the longest side. So the height has to actually be under 61. So C and D actually already drop off the problem because of that. Now, to do this problem, we need to know a formula that finds the distance of a right triangle. On your GED test, there is a formula sheet, and on your formula sheet towards the bottom, there's what's called the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. So we need to know that formula to do this problem, the Pythagorean theorem. So the Pythagorean theorem means we have this a squared plus this b squared is equal to c squared. But what does that even mean? Well, instead of using words, a lot of times they'll use letters to represent words. So if I draw a right triangle, You have to forgive my sketches, but the A and the B are the sides that make the right angle. And the C is the long slanted side. So when I'm using the Pythagorean theorem down here, I have this A squared plus this B squared is equal to C squared. That's going to be the relationship that I need to know. Without that, I cannot do this problem. So that's the relationship, is the Pythagorean theorem. And in this relationship, we have to understand where these numbers go. The A, we don't actually know what it is, or we can call it H. I'm just going to leave it as A squared. It's the unknown. That's what we're going to be looking for. The B is the distance across the bottom. That's going to be the 11. That's 11 squared. And then we have then this C squared. Well, C was the slanted side. That's at 61. So it's at 61 squared. So you also got to know a little bit about exponents. So to do this problem, we can clean it up a little bit by squaring 11. So see if I can find a calculator that will help me out a little bit. I don't think I really have a real good calculator here. But I do know that 11 squared just means 11 times 11. So I'll get this calculator out of the way and give me a more simple calculator. 11 times 11 is the same thing as 11 squared. That's 121. So I'm going to replace that with a 121. And then the 61 squared means 61 times 61. So 61 times 61, that's going to be 3721, 3,721. So what I can do now is bring the rest of the problem down. A squared plus 121 equals then this 3,721. If you don't know how to solve equations, what you can do is just substitute A and B into the problem. So if I put 50 in, that means 50 squared. 50 squared is 50 times 50. That's going to be 2,500. And then if I add this 121 to it, that gives me 2,621. But I was supposed to get this 3,721, so that's not big enough. So that means that B would have to be the correct answer. So if I wanted to just go ahead and verify that, I could go 60 squared is 60 times 60. That's going to be 3,600. And then if I add that 121 to that, that's going to give me then this 3,721. So that could be a strategy we can use to kind of solve this problem. So B would be the answer to this one, that's 60 feet. So remember, in a right triangle, the slanted side is always the longest side. So the 61 has to be the biggest. So that means that these two sides have to be smaller than 61. That's why I ruled out C and D, which then I didn't have to do as much guessing and checking. Got it down to 2. Okay, let's see if we can move on to the next question. So we have a cabinet maker sells cabinets as shown in the table. So we have these dimensions, and we have each face of the cabinet of model 213C is in the shape of a rectangle. What is the volume of 213C in cubic feet? So one thing we have to pay attention to in this problem is the dimensions. The dimensions are in inches, but volume has to be in cubic feet. So to do this problem, we need to be able to convert inches into feet. And since there's 12 inches in a foot, that can kind of help me out. We're also focusing on 213C, so that's these numbers here. So 24 would turn into 2 feet. The 72, I'm not really sure about that. I might have to get a calculator out. So if I divide 72 by 12, that would tell me how many 12s are in 72. 6. So 6 feet. So 6 12s would be 72. That makes sense. So that's going to turn into a 6, and then 18 inches, well, 12 inches is going to be a foot, and 6 inches is a half a foot. So that's going to be like 1.5. So it's actually going to be so the word by actually means multiplication. So it's 2 by 6 by 15, actually 1.5. So 18 inches, again, if you weren't sure, you could also just divide 18 by 12, and that would give you 1.5 inches as well. So if you're unsure where I got that, just divide the 18 by the 12, and that would also give you the 1.5. Now, again, it says volume of this shape. So if I'm using my formula sheet, volume kind of involves a rectangular prism here, would be length times width times height. And that's kind of going along with this word by, kind of implies this multiplication. So to find the volume of this, all I got to do is use my calculator and multiply, 2 times 6, of course, would have been 12. And then I got multiplied by 1.5. That's going to give me then this 18. So the answer to this problem would actually be 18 cubic feet. So 18 cubic feet would be the answer. So the trick of that one is these units are in inches, but the answer wants to be in feet, cubic feet. So it's a good idea to convert the inches into feet first and then do the multiplication. So we know that 12 inches is a foot. So that's kind of the information I have to bring to the table. The relationship, of course, volume of a cylinder, of a rectangular box, if you will, is just a multiplication problem, length times width times the height. Okay, so that concludes that problem. So this next question, together Laurel and Hardy earn $4,680 per month. Laurel earns $520 more than Hardy. How much does Laurel earn per month? So together they earn $4,680. So they're splitting this money, but they're not splitting it equally. But if I did split it equally, that would be a kind of a start. So if I do 4,680, 4,680, if I divide that by 2, that would give me this 2,340. And that means, the answer would have to be around that area, but notice how Laurel earns $520 more than Hardy. So to me, we got to do some more math here. So to me, all this is going to be is an estimation. So what I can pick up on is, in using algebra, what I can say is, if Laurel is going to be represented by X, Hardy is going to be $520 less, like that. So it looks like we have to do some algebra on this thing a little bit, since I didn't have multiple choice. And together they earned 4,680 in this problem. So if I say X represents Laurel, Hardy would earn $520 less. So I have to subtract 520 from Laurel. Now, if you know a little bit about algebra, well, X and an X will give me like this 2X minus this 520. And that'd have to give me then this 4,680. Now, to solve an equation, we can kind of use what we call inverse operations to get X by itself. So we have to isolate this X. And the way we can do it is get rid of subtraction first by using addition. So I can make that 0 out by adding a 520 here, But if you add a 520 here, the property of equality says you have to add a 520 over here on this other side. So this would zero out actually, and 2x equals then this. So let's go, let me do that math over here. So 4,680. I have to add 520 to that. That gives me this 5,200. So 5,200. And then to get x by itself, I'll have to divide this by 2 to make the 2's go away. And then you have to divide that by 2 to keep the equation balanced. So the math boils down to I got to take half of 5,200. So if I clear off my calculator, so if I divide that by 2, that gives me 2,600. So 2,600 would be the answer to that problem. 2,600. That's how much Laurel made. And if you subtract 520 from that, because since he earned more, if I subtract 520, that would have gave me 2,080. And together, if you add those together, that should be 4,680. So that problem would come together in that sense. But if I just know that, if as a guess, if they split it 50-50, Laurel would get 2,340 and Hardy would get 2,340. But since Laurel earns more, we know the answer's got to be at least more than 2,340. So that kind of fits our estimation as well. So we did a little bit of an estimation, but it kind of hit dead in the tracks because this was not a multiple choice question. Okay. See if that helped a little bit. The design of a new cone-shaped container is shown below. What is the surface area of the container in square inches? So again, we pick up on some key words. Surface area. It also talks about a cone. So using my formula sheet, I may be able to find a formula involving surface area. So surface area of a cone is this formula right here. So surface area equals pi rs plus pi r squared. So if I write that down, so the surface area is going to be pi rs plus pi r squared. Now to find the surface area, looking at the answers, pi is still left in the answer, so I don't have to change pi to 3.14. It stays in the problem. But remember, pi rs means this is all multiplication, so that means pi times r. R is the radius, and the radius is the distance from the center out to the edge. The only number they give me is this 4 inches, but that's the diameter. So you got to remember that the radius is half of the diameter. So if the diameter is 4, the radius is actually going to be half of that, which would be 2. So that's going to be a 2. The S in this problem, well, the only number I see is the slant height is 6 inches. So the slant height is this distance here. So that was our S is the 6. So we multiply that by 6. And then we add to that, and again, we don't have to change pi to 3.14. We just leave that in the problem. Times then, the radius is, again, 2, and we do 2 squared. So it's 2 squared. So to clean this up, since multiplication is commutative, order can change. So I can go ahead and just multiply 2 times 6 is 12, and I can just say that's 12 pi. And then I can add to that, and 2 squared is actually 2 times 2, which is 4. I can reverse that and say it's 4 pi. So 12 pi plus 4 pi, what that basically saying is how many pi's are present. All you got to do is add what we call these numbers in front, the coefficients. So 12 and 4 will give me this 16, and that would be then 16 pi. That's how I could work that problem out. So 16 pi would be the solution. So again, I can take advantage of the formula sheet, and I got to understand that these variables have meaning, and I have a diagram to help me understand the meaning. Just replace those letters with their numbers. The other thing you have to remember is the relationship pi rs are all related by multiplication. I'm allowed to use a dot for multiplication. And remember that 2 means an exponent there. The radius is being raised to a power of 2. So you got to actually square that 2 to get that 4. And then, of course, then we get this 12 pi plus 4 pi, which then turns into 16 pi. So that's kind of our thinking on that problem. So again, the relationship actually comes from our formula sheet. So simplify this polynomial. So simplify kind of means work this out, but it's not working it out like we normally do because they don't tell us what the letters are. So the letters have to stay in the problem. So notice how these letters don't disappear. They stay in the problem. So we have to kind of clean this up a little bit. One of the first things we got to remember, though, in simplifying, we have to use what's called the order of operations. Please excuse my dear Aunt Sally. And one of the things that we focus on is these parentheses. So when I have parentheses involved, what has to happen, though, is this -2 has to go and multiply through the parentheses. So -2y means -2 times y. And remember, when you connect a number next to a letter, you don't have to put a multiplication symbol. Plus then, and then you got to multiply the -2 to the x. So -2x is just -2x. So that just turns into -2y plus -2x. So if I bring down the rest of this problem, I have this 3x cubed plus x plus 2x cubed minus this 4x squared plus this 14y plus then this minus 2y plus this -2x. So when I circled that, I got to remember there's going to be a plus sign there in front to make it a little bit easier. To combine like terms, the way we do this is we have to focus on the variables. The variables that are the same with the same exponent are like terms. And when they are like terms, all you got to do is focus on the coefficients. So this 3x cubed and this 2x cubed are what we call like terms. So I can put those together. So that's going to be then this 5x cubed. So those are out of the way. Then there's this x squared. I don't see any other letters that have an x squared in them. So that can just drop on down next to the 5x cubed. So I'm seeing 5x cubed minus 4x squared. Right now, the only ones that I'm seeing that are really only D is showing that. So at this point, I could probably say that's the answer without doing anything else. But if I want to go ahead and verify this math, what we have now is this x and this -2x. And remember, x really means 1x. So what you really got to do is add a 1 to a -2. And you can use the calculator if you need to. 1 plus -2 would still just be a -1. So that's going to be a plus. It's going to be a plus a -1x. So that takes care of that term. And so that term's gone and that term's gone. So the only thing that's left is this 14y and this -2y. 14y and a -2y would end up being a positive 12y. So we end up with then this 5x cubed minus this 4x squared plus -1x minus this 12 plus this 12y. Now that looks a little bit different, but notice that I can drop the addition symbol, but that negative has to turn back into a subtraction sign if I do that. I can reverse that process. And the 1 doesn't have to be there. 1 is understood to be there, so I can just say drop the addition. The minus sign turns back into a subtraction sign. That just turns back into an x. So those are equivalent. So it does kind of match up there. Okay, so that kind of takes care of that problem. So the distributive property is when you got to multiply through parentheses to remove parentheses. That's the big thing. And if there's a sign out in front of the number, you got to take the negative sign with it to make it easier. So number 8, this is the 8th one we're going to do here. So now we have this coordinate grid. A rectangle is drawn on the coordinate grid. 3 of the 4 vertices are located at the points -1, -2, -1, 4, 2, -2. What's the location of the 4th vertex? Now, again, on the GED test, you would not be able to mark on this. You'd have to draw your own X and Y axis again. So if you draw your own X and Y axis, remember the numbers on the axis are actually, they're on the axis, and these numbers are on the Y axis. So when I say -1, -2, -1, you have to start at the origin, which is where that 0 is. -1 means to go left 1, and -2 means to go down 2. So that would be this spot over here. -1, 4, you'd have to go left 1, and then up 4 would be at this spot. 2, -2 means you go again from the origin, you have to go right 2 and down 2. So that would be at this spot. So again, what they're saying is you got to have a rectangle. I'm kind of seeing a rectangle starting to show up here. There's one side, there's their side. The other side would have to be over here and like that. So what's missing is this spot right here. So that would be 2, 4 would be missing. So the order pair 2, 4 would be what would have to be found. That's the location that would be needing. So 2, 4. Again, vertex is another word for point. So these endpoints here are also called vertex or plural vertices. And again, you have to know a little bit about plotting order pairs to graph that. That would be our relationships that we have to come up with. So which of the following expressions is equal to the expression? So again, notice how we got this expression, but they don't tell us what numbers to put in place of the letters. So if you look at the answers, the letter stays put. So what I got to do is I have to work this problem out, keeping the letters in it. And when we do that, that's referred to as simplifying. And when you simplify, usually we call that the order of operations. That's that please excuse my dear Aunt Sally thing. Let's see, that's a -9 there. So remember, to remove these parentheses, since there's a number out in front, this 2's got to multiply through the parentheses. That's distributive property. But to make this work, really, you got to put that -2 with it. And what you do is you multiply the -2 through both pieces on the inside. So that's my first move, is that. So -2 times 3 is -6, and then the x just comes along for the ride. And a -2 times a -9, because there's 2 negatives present, that's going to be a positive or a plus 18. So that removes the parentheses. So this 4x has to come down, and I'm going to just put an addition symbol there since I made that a -6. So I have 4x plus -2x plus 18. Again, those like terms would be this 4x and this -6x. And to add like terms, all you got to do is add its coefficients. So 4 plus -6 is going to be then this -2, x comes in, and plus then this 18. So I should have this -2x plus 18. So I see this -2x here, but notice how that's got a -18. This one up here on A, actually, remember, this can be reversed, and I'm allowed to make that minus sign, the negative sign turn into a minus sign as long as I make that back to a 2x. So I can kind of reverse that process. So actually, 18 minus 2x would be the answer to that one if we follow the way to simplify expressions using the order of operations and combining like terms. But remember, the key is removing those parentheses, and that neg number has to go through there as well. And again, you can take advantage of that calculator as long as you don't put that letter in there with that. So number 10, we have this equation, 3x squared minus 10x equals 8. And it says, which of the following values of x will make the equation true? So the only way I know how to do this is they're actually giving me the values of x's down here. They're giving me 4 different numbers to try for x. So since the variable is known in our answers, I can substitute those variables, those values in for x, and then I can kind of work the problem out. So I have 3 times x squared. And remember, when you're multiplying with neg numbers, it's a good idea to put the -4 in parentheses. And then the power 2 goes on the outside. Minus then, we have this 10. Again, since that's 10x, that means 10 times x. I'm going to place -4 in there. And then my answer's got to be 8. So I'm going to try this here. And again, since I don't really have a good calculator, I have to follow the order of operations. So I have to do exponents first. -4 times -4 would be 16. And then 3 times 16, if I do that math. So 16 times 3. 16 times 3, that's going to end up being then 48. So this turns into a 48. Again, if you have a calculator, you can just type the whole thing in. So this is going to be 48 minus, then 10 times -4 would be -40. And then if you have a minus and a minus, that really is the same thing as 48 plus 40. I like those two numbers, but the sign's wrong. That ended up being 88. So I really like this 4 because that was 8 apart. So I'm going to try the other 4 before I move to the 3s. So by just making an observation as I'm doing the math, maybe I get lucky here and only have to do 2 guesses. So 3 times 4 squared minus then 10 times 4. Well, 4 times 4 is 16. 3 times 16 is at 48. Minus 10 times 4 is 40. 48 minus 40, I like that. That's going to be 8. That's going to check out. So D would be the answer. So again, I can use some guessing and checking to solve that problem. Let's see if we can do one more and then we'll take a break. So an inequality is shown. 12 times the quantity x minus 2 is less than 24. So again, they want to know us what the value of the x is. So again, we're getting into math that really requires a little bit more than just general knowledge. You actually have to know a little bit about working with algebra. So our goal is to figure out what x is. Notice how there's just an x on one side of the inequality. My goal is to basically what we say is isolate the variable. But to isolate the variable, we have to kind of clean up each side. And to clean up this side here, this 12 is connected to this x minus 2 with parentheses. That's that distributive property. So this 12's got to multiply through the problem. So 12 times x is going to be 12x, because that means 12 times x. And 12 times 2 is going to be 24, so that's going to be minus 24. And then this has got to be then less than 24. So our next move is to get x by itself. This is where I can actually treat this like a property of equality. So the property of equality says I'm allowed to get x by itself by getting rid of the subtraction first, but I have to use inverse or undo subtraction by adding a 24 here as long as I add a 24 to the other side of the inequality. So then I rewrite my new inequality. So these will zero out. That leaves me my 12x is less than 48. And then to get x by itself, since this is multiplication, we're allowed to divide each side by 12. And if I use my calculator, 48, I already got one there, divided by 12 is going to be 4. So 48 divided by 12 is 4. So I end up within x is less than, oops, wrong one. Let's get that off there. So x is going to be less than 4. And that kind of triggers us to this problem right here. So that's one of the things we can kind of pick up on with inequalities, is you can kind of treat them like equalities. There is a property of inequality that's important, but I don't see it present here to worry about it, so I'm going to leave that alone. So that's going to include our part 1 of the GED and review of algebraic reasoning and working with a little bit of geometry. So I hope you found that helpful.